Hey guys, welcome back to another video, and today we're going to be solving the LeetCode question, all elements in two binary search trees. Alright, so in this question we're given two binary search trees. One of them is root 1 and then root 2, and we return a list containing all integers from both trees sorted in ascending order. Okay, so let's just start off with what exactly a binary search tree is and how we can start off to solve this question. So let's say we're given this binary search tree as an example. So what is a binary search tree? So in simple words, it's a tree-based data structure which follows the rule that all the left nodes are smaller than whatever the root is, and everything to the right is greater than whatever the root is. For example, let's take the root as 8, and everything to the left of 8 should be smaller than 8. So over here we have 3, 1, 6, 4, 7. They're all smaller than 8. Now if you go to the right of 8, everything is going to be greater than it. So over here we have 10, 14, and 13. They're all greater than 8. And let's just say one more example. So let's take 6, and let's assume 6 to be our root. So whatever's to the left of 6, which is 4, has to be less than 6. And it is. 4 is less than 6. And over here we have 7, and obviously 7 has to be greater than 6. And in this case, that's true. So now what we want to do is, we know this follows a certain set of rules, which all binary search trees follow. And we want to extract that information in such a way that we get all of the nodes' values in ascending order. So this is how our output is going to look like. We're going to have 1, 3, 4, 6, 7, 8, 10, 13, 14, which is in ascending order. So this is going to be for one of our trees. And we're going to do the same thing for another one of our trees. So that's what we're going to do, but let's just see how we can do it for one of our trees, and then all we're going to do is we're just going to replicate it for a second time. So what we're going to be using is we're going to be using the in-order traversal. So in an in-order traversal, in simple words, you go to the left, then you go to the root, and then after that you go to the right. So let's see how that looks like real quick. So our first step, we're going to start off at our root over here, and we're going to go to the leftmost element. So we go to the left here, and we end up at the value 1. So why do we go to the leftmost element? Because the leftmost element is always going to be the smallest element. So first we're going to get our leftmost element, which is, 1. So now we have 1. And now we're going to go to our root. So our root has a value of 3. So now we're going to add 3. And now we're going to go to our right. So we're going to end up at 6. But 6 is actually not a leaf. So once we reach 6, we're going to go to its left, which is, 4. So we're going to add that. And now again, we're going to go to the root, and the root is 6. And after that, we're going to go to the right, which has a value of 7. And why are we adding the 7 here, and why didn't we add 6 earlier? The answer is because 7 is a leaf, right? So there's nothing, 7 does not have any children nodes. So the same way, so we're completely done with this part. So we're done with the left of 8. So in this case, we're going to go back to the root, which we started off as 8. So we're adding 8, and now we're going to repeat the same to the right. So over here, we're going to check if it has any left children. It doesn't. So we're going to end up adding the value of 10. And then we're going to go to 14. And 14 does have a left child. So we're going to add that left child, which is 13. And then we're going to end up adding 14. And it doesn't have any right children. So we're done. And this is how we get our in-order traversal. And an in-order traversal of a binary search tree is going to end up giving you a list in an ascending order. So now let's see how we can write this in code. Alright, so let's start off with our code. And one thing that we want to notice is that we already have a class called treeNode, which is predefined for us. So inside of this class, we have 3 attributes. We have one which gives us the value, we have one which gives us the left child, and one which gives us the right child. Okay, so what we're going to do is we're going to create a function over here, and we're going to call this function in-order. So we're going to be using this in order to perform an in-order traversal on each of our binary search trees. So what is this going to take as argument? So we're going to give it self, and we're going to give it some sort of list. And to this list, we're going to append our elements one by one. So I'll just call this list L, and we're also going to give it the node. So the node is going to be the root node. So it's either going to be root 1 or root 2. Okay, so how are we going to start off with this? Okay, so over here, we're going to have our base case, which is going to check if it's a leaf or if the node even exists. So in this case, how can we do that? So we can do if node is none, Or in other words, we could just type if not node. So that's the same as checking if the node has value of none. And in that case, we're just going to return. Okay, and if that is not the case, else, we're going to go inside of this else loop. And over here, we're going to call the self.inOrder function. So we're going to call this inOrder function on itself. And we're going to end up giving it the same thing. So we want to give the same list, which is L, and we're going to give it node.left. And the reason we're giving it node.left is because we want to go to the left first. So that's why we're giving it node.left. And now it's going to perform our inOrder traversal on the left subtree. So after we do that, we're going to append that node's value to our list. So l.append, and we're going to append the value. So node.val. Okay, so, and after we do that, we want to iterate or go to the right subtree. So we're going to call the function again, so self.inOrder, and this time we're going to call it on the right subtree. So we're going to give it the same list L, and we're going to call it on node.right. Okay, so that should be it. And by the ending of this, once we're done with this part, we're going to have all of our nodes inside of our list L in ascending order. So at this point, what we're going to do is we're going to return that list. So we're going to end up returning L. So that's it for our inOrder function. And let's see how we can work with that inside of our main function. So we're going to start off by creating our list. So I'll just call this list underscore, and this list is going to include the ascending values of both root 1 and root 2. So we could create two different lists, but that would actually just take up extra memory, which is not really necessary. So we can do this all in one list. So in the beginning, what we're going to do is we're going to call the self.inOrder function, and we're going to end up calling it on our on the first binary search tree. So we need to give it the list. So in this case, list underscore, and we want to give it the tree. So in this case, we're giving it root 1. So by the end of this, we're going to have a list which has all of the nodes values in ascending order for the first binary tree. And after that, what we're going to do is we're going to call the same function, but instead we're going to call it on the second binary tree here. And notice how we're doing it on the same list, and that just saves up memory. So after this, we need to sort that list. So currently we have a list and half of it is sorted. So the first half is sorted and the second half is sorted. So now what we want to do is we want to take both of these two sorted halves and make it sorted completely. So to do that, all we're just going to do is we're going to call return sorted, and we're going to give it our list over here. So this sorted, actually, I didn't know about this and it's pretty interesting. So what it does is it actually sorts it in a big O of n time. And the reason for that is it uses something called Tim sort. So in this case, let me just show you an animation for it. I'll put a link to this animation down below. So over here, you can see that the first half, so this part over here is sorted, right? It's in ascending order. And this part over here is also sorted, right? So we have two parts, each of which are sorted. And now we want to make it in such a way that together, combined, they are sorted. So let's just run this. And everything actually happens in one iteration, as you can see. So that's what we're going to be doing. And that actually is inbuilt into Python using the sorted function. So that's actually really fast. And yeah, so let's submit this. And as you can see, our submission is accepted. And finally, thanks a lot for watching, guys. Do let me know if you have any sort of questions. And don't forget to like and subscribe if this video helped you. Thank you.